Example 3, brought to you by our local sponsor, Napa. Actually, Josh gave me this hat yesterday when I was in picking up a pole cord for my wood splitter. So, today, I'm looking at example 3, page 304. And all it is a word problem. So let me read it to you here. You should follow along on technical difficulties. Page 304. A super slide charges $1.25 to rent a mat and 75 cents per ride. Foster has $10.25. How many rides can Foster go on? So choose a variable, then write an inequality to solve the problem. Solve the problem, and then graph the solution. All right, so we're going to make a variable. No, we're going to make an inequality from that information. So let me see. They're going to charge me $1.25 for the mat. All right, $1.25. Then they're going to charge me 75 cents a ride. All right. Plus 0.75, and I'll use the variable r for ride. How many rides can how many rides can Foster go on for $10.25? So my $10.25 has to be greater than or equal to my $1.25 plus 75 cents a ride. So the first thing I'm going to do, let me see. So we know we're going to be trying to get this variable by itself. So I'm going to send the $1.25 over to the right. So that'll leave me with 0.75 less than or equal to the $10.25. It's already there. This is a plus $1.25, so it'll have to go over as a minus $1.25, leaving me with, that R should be in there, 0.75 R is less than or equal to 9. I have to get rid of that 0.75 or send it over to the right. It's a multiplication, so it'll have to go over as a division. 9 divided by 0.75. And when I do that, it gives me 12. So R is less than or equal to 12. Again, it was a written question, so I have to answer it. So let me see. Foster can go on 12 or fewer rides. So what else do they want us to do? So we've made up the equation that they've asked for right here. We've solved it. We've answered it. And they want me to graph it. Graph that. You know, that graph is going to look a little bit different than what we're used to. So it's going to be 12 or fewer rides. So let me see if I can get that all on here. 12, 11, 10, 9, 8, 7, all right, This time I went from 0 to 12. And so I look at my equation. I'm going to start off at 12. And what I'm going to do now is I could be 12 rides or 11 or 10, 6, 5, 4, 3, 2, 1, or it could be 0. Now the reason that, how normally we just have something looking like that, and we'd have our dot and we'd arrow it in over here. The reason that they didn't arrow it in, that they put the dots on, if you look at rides, I can't go on like 11.1 rides or 11.2 or 2.5. I'm either going to be 12, 11, 10, 9. So I guess it would be like discrete, like one ride. Anyway, I'm sure you have. That's why it works like it does. So now, questions I'm going to have you do. Page 305 and 306. And I want you to do questions 8, 10, 13, and 18. All right? And again, I'll send all the answers along with you so you can check my work. If you're having problems doing it and you can't get an equation set up, then the logical thing to do is go have a look at mine and then go back and try to do the problem. I think next week I'm going to speak to you about something else. I've been hearing, I don't know, like a bit of grumbling around, and well, from everybody. Some teachers, and some students, and some parents about doing this work. And I just want to talk to you a little bit about why I think this stuff is somewhat important. All right. We'll see you next week. Good luck. Don't forget to send in your stuff.